So with lesson 6.4, we're going to start talking about x-intercepts. And specifically today, we're going to be talking about something called multiplicity. But before we do that, we're going to just briefly go over some important things about the x-intercepts. And first of all, you know an x-intercept is the point where it crosses the what? X-axis. So a polynomial, let's say it has a degree of n. So whatever that degree is, 2, 4, 7, 9, whatever. That's the highest exponent. That polynomial can have at most n real zeros. Meaning if the degree is 7, my graph isn't going to cross more than 7 times. If my degree is 3, I can't have more than 3 x-intercepts. And even more specifically, if the degree is even, the polynomial has an even number of zeros. And if the degree is odd, it has an odd number of zeros. So just because my degree is 7 doesn't mean that it absolutely will have 7 x-intercepts. It could have up to 7. And if my degree is 7, it could have 1, 3, 5, or 7 x-intercepts. Cannot have an even number. But we're going to get into something that's kind of like an exception to that. And that's where the multiplicity comes in. So we're going to do just one graph. We're not going to do both of them. So here I have x cubed plus x squared minus 2x. How many x-intercepts could you expect this graph to have? 3 or 1. I could have 1 x-intercept or I could have 3. So it's an odd number. I could have any odd number of x-intercepts up to 3. So 1 or 3. Okay. So if we go into y equals, and I type in x cubed plus x squared minus 2x. I'm going to look at the table. You don't necessarily have to get the max or the min. We're just looking at x-intercepts. So negative 2, 0, negative 1, 2, 0, 0, 1, 0, 2, 8. So this does in fact have 1, 2, 3 x-intercepts. And so those x-intercepts are at negative 2, 0. Where's the next one? 0, 0, and 1, 0. Those are my 3 x-intercepts. So let's get into, on the next page, what we call multiplicity. When we have a polynomial, generally they are all in standard form. So for example, I might have x cubed plus 7x squared plus 2x minus 1. That is standard form. Sometimes we will have a polynomial in what's called factored form. And we factored quadratics in Unit 5. We're going to be spending a lot of time over the next few lessons factoring polynomials that aren't just x squareds. So we're going to be learning some new factoring methods. And so when we factor, we might have something that looks like this. X plus 2, x minus 5. You've seen that before. We might factor something and it might be x minus 3, x minus 3. Which is really x minus 3 squared. When you multiply something by itself, that's the same thing as having x minus 3 squared. So when we talk about multiplicity, we want our polynomials to be in factored form. So the multiplicity is talking about how many times I have a specific factor. So over here, I had both of these factors as x minus 3. I had 2 of them. So my multiplicity was 2 because I had that factor 2 times. So when we start talking about the multiplicity, we're going to be looking at the exponent. That tells us how many times we have that factor. And then in a few minutes, I'll show you what the multiplicity actually means for the graph. So let's start here with number 1. When we factored in Unit 5, and I said to find the x-intercepts, what did you do with the factor?
Set it equal to 0?
Yes, we set it equal to 0. So I'm going to take a factor, just what's in parentheses, I'm going to set that equal to 0. And I'm going to solve that for x. So I would get x equals what? X equals negative 2. Now because there's a squared, that means that I really have this factor 2 times. So my multiplicity is 2. So when I said on the front that an x-intercept, like if you have an odd degree, you would have an odd number of x-intercepts. Well, if the multiplicity is 2, this technically counts as 2 x-intercepts. So even though it only goes at negative, you only see the 1 point. We only see negative 1. It's counted as 2 when we're talking about the odd and even numbers. It's not that super important. And then we have another factor at 2x plus 5 equals 0. So I can subtract 5 to get 2x equals negative 5. And then divide by 2 to get x equals negative 5 over 2. And what's my multiplicity? 3. I'm going to show you the graph of this. Well, this wasn't a very good one to look at. So this one technically has an x-intercept at negative 2, which is right here. And then it also has one at negative 2.5. So you can't really tell that with the graph because it's really close to the line. But there's technically 2 x-intercepts, but my degree would be 5 because I have a multiplicity of 2 and a multiplicity of 3. You don't have to focus too much on that. As long as you can tell the x-intercept and what the multiplicity is, you'll be good. So number 2, this x squared that's in the front, I still treat that like it's its own factor. So I have the x equals 0, but there's nothing to add or subtract. What's my multiplicity? 2. Then I have x minus 7. And I add 7 to both sides to get x equals 7. And it has a multiplicity of 6. So that one technically counts as 6 x-intercepts. And then I have 2x plus 1 equals 0. So subtract 1, divide by 2, I get x equals negative 1/2, and I have a multiplicity of what? 1. Good. It's just there once. If there's not another exponent, it's just 1. Any questions? Number 3, we have the x in front, so we do x equals 0. And what's its multiplicity? 1. And x minus 3 equals 0. X equals positive 3 with a multiplicity of 2. Then number 4, there's just a 2 in the front. You don't need to do anything if it's just a number. If it has an x with it, then yeah, you set it equal to 0. But if it's just a number, you don't need to do anything. And we have 5x minus 3 equals 0. So 5x equals 3, or x equals 3/5, with a multiplicity of what? 3. And negative x minus 7 equals 0. Add 7 and I get negative x equals 7. Divide by negative 1, I get x equals negative 7. With a multiplicity of 2. So we're going to actually look at the graph to see why do we even have a multiplicity, what does it even mean? And it tells us something about the graph at that x-intercept. So I picked example number 3 that we already did up here. We know we have an x-intercept at 0 with a multiplicity of 1. And we know we have an x-intercept at 3 with a multiplicity of 2. So I have an x-intercept at 0 and an x-intercept at 3. I'm going to go to the graph. So if I look at the two x-intercepts, what's happening at those points is a little different. This one, what's the line doing at that point? What's it do to the point? It like completely goes through it, right? Goes from one side to the other. So we're going to say that it crosses there. It actually goes in one side of the point and out the other. But at this one, that's not the case. It doesn't go outside, in one side and out the other. It like hits the point and bounces off of it. So it's like a ball that bounces. So we're going to use the word bounce. The multiplicity tells us if the graph is going to cross or if the graph is going to bounce at the x-intercept. So if the multiplicity is odd, here I had a multiplicity of 1, which is an odd number. Did my graph cross or bounce at this x-intercept? It crossed. The graph crosses. If the multiplicity is even, so if it's an even number, it bounces. One way that you could remember that, the word cross has 5 letters, which is odd. The word bounce has 6 letters, which is even. That's kind of a way to remember. So we just have 3 examples. We're going to do what we did on those first few, and we're going to write the word bounce or cross over here. So we're just going to add that step. So, number 5, here is one of my factors. So I've got to set that equal to 0. So I get x equals -7. So that's my 0 or my x-intercept. What's my multiplicity there? 2. So based on what we just said, am I going to bounce or cross at -7? Bounce. Then we have 2x plus 1 equals 0. So I can subtract 1 and then divide by 2. So I have an x-intercept at -1/2. What's my multiplicity? 1. If you don't see an exponent, it's 1. Which means that what's going to happen at that x-intercept? It's going to cross. And then I have x minus 4 equals 0. So if I add 4, I get x equals 4. And what's my multiplicity? 3, which means I cross. So let's see. Sometimes when you have like a lot of exponents, they don't always look the best on the graph. But let's see. I should have x plus 7. I'm not sure why that one didn't show up. I have to look at that one. Yep. All right. Go on to number 6 and see if you can fill out the chart. Okay. So you should have an x-intercept at 0. With a multiplicity, and it's going to bounce there. 5 halves with a multiplicity of 1, so it's going to cross. And then -3 with a multiplicity of 2, so it's going to bounce. Are there any questions on that? The last one I want you to try by yourself for a minute. A polynomial function has a 0 or an x-intercept at -6 with a multiplicity of 2 and an x-intercept at 2 with a multiplicity of 1. You're going to write a polynomial that kind of looks like this or looks like this that fits that description. Alright, so we should have f of x equals, or you could have put y equals, and then you should have had something in parentheses. What did you put in these first parentheses? X plus 6 squared, good, and then you should have another set of parentheses and it should say x minus 2. What about an exponent? The multiplicity is 1, so we don't generally put a 1 there. So, I mean, if you put it, it's not wrong. But this is the right answer.
It says -6.
Right, so but here, if I had x plus 3 and I set that equal to 0, my x-intercept ended up being -3. So it's kind of opposite.
Could you have done negative, after the x plus 6 squared, could you have done halfway through x? Or?
No, it has to be like this.